13.8 billion years ago, everything you see today, from atoms to massive galaxies, emerged from a minuscule singularity. Space-time itself expanded at an incredible rate in a tiny fraction of the first second. Fundamental forces separated, and the building blocks of the first hydrogen and helium atoms formed. Massive stars were born, and their spectacular deaths created all the elements that make up our bodies. We are part of this cosmic legacy. In this episode of Astronomy for Beginners series, we will explore the brief history of the 13.8 billion-year-old universe. The story of the universe began with a tremendous and instantaneous expansion of space itself. At first, all matter and energy were compressed into an infinitely small point. Immediately after, an incredible event occurred, lasting less than a trillionth of a second: cosmic inflation. Inflation expanded the universe many times faster than the speed of light, creating the remarkable uniformity and flatness we observe today. Once inflation ended, the universe became a chaotic quark-gluon plasma soup at trillions of degrees. In these earliest moments, the four fundamental forces, gravity, electromagnetism, the strong nuclear force, and the weak nuclear force, gradually began to separate. In just a few seconds, as the temperature dropped slightly, quarks finally combined to form protons and neutrons. And we've reached one of the most critical moments in history: the first 3 minutes. When the universe's temperature dropped to about 1 billion degrees, protons and neutrons began to fuse, or in other words, Big Bang Nucleosynthesis started. This nuclear fusion forever determined the chemical composition of the universe: about 75% hydrogen and 25% helium. However, at this stage, only atomic nuclei formed. The universe was so dense and hot that free electrons couldn't attach to nuclei, and light was constantly being scattered. The universe was hidden behind a dense and opaque plasma fog. After the first 3 minutes, the universe's history was relatively quiet. But about 380,000 years later, a turning point occurred: recombination. The universe had cooled to a critical temperature of about 3000 Kelvin. This was the first moment when free electrons could finally bind to hydrogen and helium nuclei, forming neutral atoms. When electrons combined, the opaque plasma that had constantly scattered light suddenly became transparent. For the first time, light was able to move freely and spread to every corner of the universe. This first liberated light formed the cosmic microwave background, briefly CMB, the faint glow that we can still detect coming from every direction in the cosmos today. The CMB is the baby photo of the universe at 380,000 years old, showing the tiny fluctuations in temperature and density, the seeds for the galaxies and clusters we observe. After light was freed, the universe entered its longest and dimmest period, the Dark Ages. Stars had not yet formed. The universe consisted only of clouds of neutral hydrogen and helium gas and mysterious, invisible dark matter. It was completely dark and silent. During this period, lasting about 100 million years, the powerful gravitational wells created by dark matter slowly pulled the neutral gas into clumps. These condensation points would inevitably ignite the universe's first cosmic light. The universe waited through the Dark Ages, but gravity didn't stop, and about 150 million years later, in the densest regions of gas and dark matter, clouds of hydrogen began to collapse. When the pressure reached a critical level, the cosmic darkness ended. The first stars, also called population 3 stars, were born. Because they formed solely from pure hydrogen and helium left from the Big Bang, with no trace of previous supernova explosions, these stars were incredibly massive, hundreds of times the mass of our Sun, and very short-lived, lasting millions of years. These giants emitted ultraviolet radiation that ionized the neutral gas, a period we call reionization, or the cosmic dawn. This was the moment the universe began to emerge from darkness and light up. The legacy of these first stars is what literally makes us. At the end of their brief lives, they ended in spectacular supernova explosions. In these cosmic furnaces, all the heavy elements necessary for life, iron, carbon, oxygen, silicon, were produced and scattered into space. In this sense, we are quite literally stardust. About 400 million years later, this enriched material, combined by gravity, formed the first seeds of galaxies within dark matter halos. Dwarf galaxies started merging and growing. we were now entering the age of galaxies. For billions of years after the cosmic dawn, the universe's main goal was to build galaxies. The first dwarf galaxies, like massive cosmic rivers, merged and collided, eventually forming giant spiral galaxies like our own home, the Milky Way. At the centers of these galaxies were supermassive black holes, holding everything together and playing a critical role in galaxy formation. When the universe was about 9.2 billion years old, around 4.6 billion years ago, the story arrived in our neighborhood. In one of the Milky Way's spiral arms, a cloud of dust and gas, enriched with heavy elements from the deaths of earlier generations of stars, began to collapse. Compressed by gravity, this cloud turned into a spinning protoplanetary disk. The pressure and temperature at the center of the disk triggered thermonuclear fusion, and our sun ignited. The remaining dust and rock fragments collided and merged to form our planets. In the hot regions close to the sun, only rock and metals could condense, forming the rocky planets Mercury, Venus, Earth, and Mars. In the colder regions beyond the frost line, volatile substances like water ice, methane, and ammonia also accumulated, forming the gas and ice giants Jupiter, Saturn, Uranus, Neptune. During this period, our young and volcanic Earth collided with a massive body. The debris from this collision merged in orbit, forming our planet's stabilizing satellite, the Moon. Earth cooled and solidified and began to form oceans where life would eventually emerge. This biological journey, starting with simple, single-celled organisms, continued with billions of years of evolution. So where do we stand on this immense timeline? If we squeezed the 13.8 billion year history of the universe into a single year, dinosaurs would appear in December, and modern humans would step onto the stage in the very last seconds of New Year's Eve. This shows just how new and brief an event we are in the cosmic timeline. But the story doesn't end with us. Today, only 5% of the universe is made up of atoms, the matter we can see and interact with. The rest consists of invisible forces. About 27% is dark matter, a mysterious substance that interacts only gravitationally and holds galaxies and clusters together. The remaining 68% is dark energy. Dark energy accelerates the expansion of the universe. Like blowing into a balloon, the universe is expanding faster and faster. This acceleration means that in the future, distant galaxies will move away from us so quickly that their light will never reach us. Our universe is heading toward a thermodynamic ending known as the heat death. Throughout this vast history, from the beginning to the emergence of life, we still face the biggest questions. The universe is constantly evolving, expanding, and we are just conscious atoms wondering about our own origin. As you can see, we are the latest link in this 13.8 billion year cosmic adventure. Which era in this epic journey from the Big Bang to atoms, from galaxies to the solar system, interested you the most? Don't forget to mention it in the comments. If this video gave you a new and deeper perspective on the universe, please like it and subscribe to our channel. See you in the next cosmic adventure. Take care.